going to continue with the MATLAB tutorial. And what I have here on my page, anyway, for what I plan to cover, doesn't seem like a ton. So I think there should be time toward the end if anyone's questions. For instance, if anyone has gone ahead and started the first homework, then I should have time to take questions on that. Okay, so get my diary going here. Okay, so by today we'll actually be looking at files called M files that have MATLAB code in them, and so I have a few that I'll show you and dissect how more complicated MATLAB code works. But first, there's some additional expressions that I need to cover. Focused a lot on arithmetic expressions last time, as well as building matrices. But here are other expressions that are crucial in coding in general. So first we have, aside from numeric expressions, we have conditional expressions. So conditional expressions are expressions that have a value true, which in practical terms is interpreted as a non-zero value, or by default 1, or false, that numerically would be interpreted as 0. So operators that are using conditional expressions are ones that would be familiar to you, even outside code, just for mathematics. So we have the relational operators. So we have less than and greater than. And then here's how we handle, like other programming languages, less than or equal to, greater than or equal to, and then we have double equals. That is for comparison. So you saw from last time that I would use a single equals if I was assigning a value to an expression. But when you are testing whether two values are equal, it's the double equals. And then for testing if two entities are not equal, it's tilde equals. So some programming languages like C use an exclamation point equal, but here's a tilde equals, or as I like to call it, squiggly. So that would be not equal to. So as an example, if I do, for example, 4 greater than 3. Put some space in there. All right. So that will indicate that this is a logical expression when it displays it for you. And because 4 is greater than 3, then it just assigns it a value of 1. So what is the significance of labeling this as a logical expression? If I look at my variables, like I did before, using the whos command, so the result of 4 greater than 3 is stored in the special variable ands, or answer, like I described last time. It's just a single value, a scalar. And notice it only occupies 1 byte, rather than the customary 8 bytes for a double precision floating point number. So MATLAB recognizes that for a logical expression, there's no need to store it as ordinary floating point number, 1 or 0. It will use an integer. In this case, 8-bit integer, because 8 bits is a byte, ranging from 0 to 255. And then the type is logical as opposed to a double, which is how it identifies its default double precision floating point number. So at least a little bit of storage is saved. If I give something as clearly false, like 1 is equal to 0, then it's just going to assign that value of 0. All right. Be sure to interrupt with questions at any time. I might not necessarily see a chat message, just because the chat window is not visible here while I'm sharing. Okay. Now, some other operators that are used in logical expressions are logical operators. So we have and, or, not, whatever exposure logic you had, like in discrete math. And there are separate versions of these operators that are element-wise. So for instance, if you want to take if you have two vectors, for example, both of the same length, and you want to apply a logical operation like an and to the first elements of each, and the second elements of each, and so forth, then there's element-wise operators that do that. Okay, and I'll illustrate both kinds. So the logical and operator is a double ampersand. And you may have seen this from other programming languages. And then similarly, the logical or is a double vertical bar. So as an example, I said x equal to 0.5. And I have a test here. Is x within the interval -1 to 1? So if x is greater than -1 and x is less than 1. So in this case, that is true. So it will evaluate this expression first, and then also this expression, and then take the and of these expressions. So true and true will give the value of true or 1. Okay. Now, one important thing to keep in mind is about these two operators, and or. A very important concept that's actually present in a number of programming languages. I don't know if it's ever talked about in a class like CSC 101. It's a notion of short circuit evaluation. So to give an example, this expression, x or y or z. So suppose that these are three previously evaluated conditional expressions, whether true or false. And let's suppose that x is evaluated and it's found to be true. Then, because it's an or, if x is true, the whole thing is true. And since that's something that now I can easily figure out, then y and z are never evaluated. It won't even touch them. Why? There's no need. The value of the logical value of the entire expression has already been figured out. Another example, if I have x and y and z. So let's suppose that x is false. And the whole thing is false, so y and z again not evaluated. So if it's possible to determine an expression early, when the expression is being anded or together, then it will do so. And some programming languages, they might choose to evaluate everything before performing a logical operation, but short circuit evaluation means that it will not do so, and it's an efficiency thing. Sometimes I have made use of this where perhaps if y or z was evaluated, then there might be an error, but I count on the fact that if, for instance, in this case, x is true, or here x is false, that they will not be evaluated, then the expression is okay to use. So I know there won't be an error. Okay. Now, okay, that's and or. We also have a logical not, and here's the squiggly again, so that's a tilde. So for example, if I do tilde in front of an expression that is true, then the negation of that would be false, so that's the value of that would be 0. So this is how you negate any logical expression. Okay. Now, I want to illustrate component-wise logical operators. So for that, I'm going to compute and create two random vectors. Here's x and y. And I'm going to show x and y side by side using horizontal concatenation. Now, what I'd like to know is, I want to know in which of these rows do we have x greater than 3/4 and y is less than 1/2. So compare for first values of x and y, then the second values of x and y, and third values of x and y. The way I would do that, I use a single vertical bar. If it was an and, I would use a single ampersand. So beware, double ampersand vertical bar is when you're taking and or of scalars or just numbers. If it's a vector or matrix, any kind of array, you need to use a component-wise version. Otherwise, MATLAB will give you an error. So if I do that here, x is greater than 3/4, single ampersand, y less than 1/2. So we'll use an element-wise and in this case. And let's see what happens. So we get 0, 1, 0. So we look what we had here. Here we had, x was not greater than 3/4, so that made the whole thing false. Here, the second x is greater than 3/4, and the corresponding y is less than 1/2. That's why we got a true for the second row. For the third row, again, x is not greater than 3/4, so that makes the whole thing false. Okay, questions about this one? Do the same thing, or, okay, same result. But this is the second row is the only one in which either of the conditions hold. That's just coincidence because of the particular random numbers that were chosen. Okay. So now, I get to what are called M files. So these are files with a .m extension that have MATLAB code in them, and they can be executed from a prompt or by other code. Now, one thing I'll point out is when naming M files, what I would recommend is use rules for identifiers. That's a generic concept in programming languages, names that can be used for variables. So rules for identifiers are following. That use characters that are alphanumeric or underscore, and do not begin with a digit. So a lot of programming languages have those conventions for how you're allowed to name variables. I suggest using the same convention when naming M files, because that is a name of an M file, except for a .m extension, is treated like a variable name by MATLAB's interpreter. So if you make an M file and you put spaces, apostrophes, things like that, it's not going to go well for you. Please don't do it. And you'll see this in how I name M files here. Now, what you can see here on the left, I have 4 M files, so I'm going to show you these and work with them one at a time. And with each one, I'll give you a tour of a code. So the way you can edit an M file is, so I just use edit and then the name of the M file, in this case signFx. In this case, I do not have to put the .m extension. It doesn't matter. If you don't put it, then it'll assume that extension. Now, if you do this command and you don't have this file, and by the way, I will post these files in Canvas after class and also in my own site. So in this case, what it'll do is, since I have this file, let me get rid of that's code for my research. Don't want that for my students' research. Okay. So in this case, it'll open the file in the MATLAB editor. If a file does not exist, it will probably ask you if you want to create it. I actually changed it so that it won't ask me that. It'll just go ahead and create it. But that's just my personal preference. Okay. So, oops, don't want that either. Okay. Make sure I don't have any plot windows hanging out. Okay. So what exactly does this code do? The first statement, it creates a random number, generates a random number between -1 and 1. Now, the rand command generates a number from a uniform distribution between 0 and 1. But I want it to be between -1 and 1, so I manipulate it accordingly. And then I go ahead and use a disp command to print out the number. Now, what you've seen before, normally, if I'm having it print out an expression, it gives the name and it equals and shows the value. In this case, I don't want to do that. I just want the number. So I use disp for that. So you can use disp on any kind of expression, and it'll display it in some appropriate format. So it generates a random number between -1 and 1, shows me the number. And now I have our first example of an if statement. So an if statement is used to evaluate a conditional expression and then execute code based on the value of that expression, true or false. So what is actually happening here? First, we check, is x greater than 0? If so if the expression here in the if statement is true, then the code right below it is executed. So it'll print out x is positive. If the expression here is false, it will skip this code that's below the if. And then it'll either, if there's an else, it will go there. Or if there is not, then it'll just go to the code after the if statement. So if x turned out to not be positive, then it checks it as negative. And if so, displays the message. If x is neither positive or negative, the only possibility left is for a real number x anyway, like this is that it's 0, so it'll display x as 0. Once one of these clauses is executed, now here I only have one statement each, but I can't have as many statements. I'm allowed to have as many statements as I want for each case. Then the code will proceed after the if statement. Now in this case, there isn't anything more. That's the idea. Based on the values of whatever expressions we have, when the expression turns out to be true, that code is run. If no expressions are true, and if there's an else, then that code is run. Once the appropriate code is selected, if any, because it may end up doing nothing, then control passes to after the entire if statement and goes from there.
Professor?
Yes?
I think x cannot achieve -1 or 1, because random function cannot. Yes. The end ones are exclusive.
Okay, let me. Okay. Yes.
It's an open interval.
Yeah, and that's something that I've always meant to look up, and I've never bothered. So technically, my statement was not false.
Yes.
But
the comments.
But it was what?
Yeah, I mean the comments here.
Yeah.
Yeah.
So
it is open interval.
yeah. Okay. So to have the smallest possible interval, yes, it would be that.
Yes.
Okay.
Thank you.
All right. So it's like one of those things, like, oh yeah, I should check that one today. Okay. Are there any other questions about the code before we go? Yes.
Yeah, that first line again, the 2 times random.
Yeah.
1, -1. What's the 2 times for? What is?
Okay. So since rand1 is going to be between 0 and 1, I want a number between -1 and 1. So that involves like a linear mapping of the interval 0 to 1 to the interval -1 to 1. Now, the interval 0 to 1 is of length, is of width 1. The interval -1 to 1 is of width 2. So that's why I got that one.
And so you can put -1 also at the end of it to imply that that's.
Yeah. So here we have a scaling, and here we have a shifting. Yes.
So if after an if or an else if statement, or of course an else, if we have more than one statement, do you have to contain it with brackets?
No, you don't.
Okay.
So MATLAB's able to figure out. So you can think of it as, this could either be a single statement or it's an implied compound statement. No delimiters necessary. Yeah, because if this were like in C or C++, yeah, you'd have to have braces. So I should mention that and the reason for that is necessary in a language like C is because C is extremely freeform when it comes to its syntax, whereas MATLAB is not. MATLAB's a little bit more restricted. I wouldn't say it doesn't go as far as Fortran, for instance. That's heavily line-oriented. Whereas languages like C are not line-oriented at all. They just strip out all the white space and analyze the syntax from there. But lines are of significance in MATLAB. As an example, suppose I had a really long expression, and I want to break it up across multiple lines. If this were a language like C, you could just do it, and you wouldn't have to do anything differently. But in MATLAB, if I have a really long mathematical expression and wanted to have it span several lines, I have to put a ... an ellipsis at the end of the line, and then I can continue the expression on to the next line. Other questions? All right. So now, I'll just go ahead. To run this code, all I have to do is type the name. So without the M extension, so what MATLAB will do is it'll take this name that I provided. It's not already in a variable in the workspace. It will look for the file sin of x.m, and if it finds that file, then it'll run the code in that file. So let's see what happens. So this is the random number that it generated. So it is between -1 and 1, and it prints out the appropriate statement that it's negative. Now, that's one way to run this code. Another way, if I'm here in the editor, I can use this. So I can just hit the green button to make it go. And we see it ran it again here. So what shows in the command window isn't any different. So it's simulating that you type the name at the front. Now, so I want to emphasize that this M file and the other ones that I'll show you today are what are called scripts. So a, 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 So a script consists of a sequence of MATLAB statements that you can just as easily type at the prompt. So typing all these statements at the prompt, or typing them into an M file and running the M file would basically have the same effect. By contrast, later we'll see what are called function M files, where I define a function that takes inputs and outputs. But it's a lot more cumbersome to use the green run arrow functions, because having a green arrow by itself would not, by default, would not supply any inputs. But if you just have a script like this to run, then the run button is great for that. So, so we'll see later in the tutorial, like probably on Thursday, function M files. So any questions about this M file before I go to another one? Okay. You know what? Okay. Normally we can break to the 35-minute mark, or just about the 30-minute mark. This M file is going to take a while. So I'll hold a break right here. Okay. Now, for the next file, first, what I'm going to do first is run the file, show you what it does, and then I will show you the code. How it does it. So the name of the file is enter month year. You see the enter month year.m over here. Okay, so it's prompting me to enter the number of a month from 1 to 12. So I'll just pick August. And then the year. And it'll tell me that how many days are in the month, so 31 days. Whereas if I were to try and say February 2020, they'll take into account that 2020 is a leap year, so February has 29 days. Okay, so how is this accomplished in MATLAB code? So we haven't seen before in the tutorial how to prompt a user to type in something, and we're going to make use of if statements like in the last example. So I'll go ahead and open the file. Okay, so there's quite a bit going on here, but I also have a lot of comments to explain it. So first, here's how you prompt the user to enter something. So using the input function. So this is a function, and you'll learn to write functions later in this tutorial. The argument to that function is a prompt. And notice it's a string in MATLAB, and we enclose a string in single quotes. So this statement will print this prompt, wait for the user to type something in, and then whatever they type in will be assigned to a variable month. And then I do the same thing for a year. So now I have, now I'm not doing anything to validate this input. I'm just trusting the user to type in something that I can make sense of. There are ways to handle erroneous input. I'm not getting into that right now. So once I have a month and a year, what I'd like to do is display the name of the corresponding month. So here I have an array of month names called months. So I have them all shown here, also with strings. And really what we have here is a matrix of characters. So each row holds the month names, and the columns within a row are individual characters. Notice that all of these month names have trailing spaces in them. The reason for that is I have to have the same number of columns in each row. So September is the longest month name, so that one doesn't need any spaces, but every other month name may have to add enough spaces to have the same number of characters as in September. So this is a 12 by 9 matrix, 12 months, up to 9 letters in each month name. So now what I do is, I take the number of a month that the user typed in, and I use that here as a row index. So I'm taking row, this value, all columns, extracting a row from this matrix that is the name of a month, that's based on what the user typed in. So now I have a character string here for the month they typed in. Now I don't want those trailing spaces, so I remove them. So this built-in MATLAB function, dBlank, will do that for you. So at this point, I have as a text string the name of a month they typed in. Now, I'm going to use an if statement, this big long if statement, to determine how many days are in that month. Now, the most interesting case, of course, is February. So I check that first. If the month is 2, they specify February, then I'll execute all this code down to this point. And then I would skip over everything else and continue down below. That's how the if statement works. Within the if, I have another if, so you can nest if statements within each other. So only if the month is 2, I now execute this if statement. And I check, is the year divisible by 4? So MATLAB's remainder function will check that for you. So this takes the first argument divided by the second argument, and it gets a remainder. So that's what REM will return. So if the year is divisible by 4, the remainder will be 0. So here it uses the double equals again, check if the remainder is equal to 0. If so, it's 29 days. Else, I come down here, set the days equal to 28. Now, if the month is not February, then it's either a 30-day month or a 31-day month. So now I check that if the month is equal to April, June, September, or November, I'll set the days to 30. Anything else? Days will be 31. So all cases are covered. So 28, 29, 30, or 31 days. Questions up to this point? Now, once I know the number of days, I like to print this out in a nice format. So what I'm doing here is I'm building up a string. So notice the output when I ran it. This month name, comma, the year, has, and then the number of days. So the whole string is enclosed in square brackets. So what do I include in my string? First, the name of the month that I got earlier from my matrix of month names. And then I want to put a comma and a space after that. And then I want to include the year. But the year is a number. Here I need text. So MATLAB's function num to string converts a number to a string. will handle that for me. And then space has space. And then I do the same thing with the number of days that I got. Convert that to text. And then I finish the sentence. And then I go ahead and display that whole string. So this is how you can build up a string from whatever variables you have. Any questions about this code? So I should mention that in section 1.2 in the text that has a MATLAB tutorial, I assigned you most of the explorations in that section for homework 1. There were a couple that this time I chose not to assign. I had assigned them previously. One of those is to write a MATLAB script based off of this one, that if you give it, if you specify a date, so year, month, and day, that it would tell you which day it is within the year, taking leap years into account. So for example, if you specified March 1st, and if it was not a leap year, then March 1st is the 60th day of the year, so it would figure that out. And then there's another one that's particularly difficult, day of week. You specify a date, month, day, year, and it would tell you, and the code figures out what day of the week it was, and print that out. I chose not to assign it this time because I feel that, especially if you don't have much program experience coming into this, that by the time you've done the problems that I have assigned, you will have suffered enough. But I am open to giving bonus points if you want to do those anyway. So those entirely up to you. But based on how many questions I would get and how many students simply ended up like not being able to do it or just not bothering to do it. And since we're still in pandemic mode, I used up this time. But if you're looking for a challenge, then that is it. Okay. All right. Here's the next M file. So, this is something, I believe this only happens on a Mac, which I'm using here. The file with the tilde is an autosave file. And that's actually come in handy. I once had a student lose some of her code for research. It disappeared, but they had an autosave file like this one. And so they were able to recover it. Okay, so I'm going to open up this file, compute mean. So for the next concept, I'm going to illustrate for loops. So we have a for loop in this file, compute mean. So what this code does is it generates a random vector of 10 numbers, a column vector. It'll display the vector, and then it's going to compute the mean. Now MATLAB has a function for computing the mean. You can always use that, but I'm having it compute the mean here in the code so I can illustrate what a for loop is. So a for loop is used for iteration. So what I want to do to compute the mean, I want to add up all of the elements of this vector x. So here's what a for statement looks like. And it's somewhat similar to what you may have seen in other programming languages, but there are substantial differences. After the keyword for, you'll have a variable equal to some expression. What MATLAB will do is think of this expression, whatever you give it, as a matrix. And then it'll assign each column of this matrix to a variable I. Now, the most common usage is exactly what you see here, where this is some range of values, in this case 1 to 10. So this is a row vector. So assigning each column to I just means assigning each element of this array to I. So 1, 2, 3, 4, etc. So then I will have that value in here when it executes the body of a loop, which can be as many statements as you want. Here I only have one, but you can have, so just like with if statements, there's an implied compound statement here. So what it'll do is, here, the value variable m is set equal to 0 initially. Inside the loop, we add on the next element of x. So it'll add on x1, then x2, x3, and so forth, all the way up to x10. So after the loop is done, m will now be equal to the sum of all the elements of x. And then you divide by 10 to get the mean, and then display it. So the value of I keeps changing. So during the first iteration, it's 1. During the second iteration, it's 2, and so on. Questions about what is happening in the code, especially with the loop? So if I run this, so here is the generic random vector x, grab all the elements, all 10, and then it just goes ahead and computes the mean. I'm going to show you another file, last one, that also uses for loops. So you may recall from your first linear algebra course, Gaussian elimination, sequence of row operations performed on a matrix to reduce it to upper triangular form in order to solve a system of linear equations. That's something I'll get into much more in the second course, not 461, 561. But here I'll use this script that performs Gaussian elimination, although without row interchanges, to illustrate for loops, especially nested for loops. So I generate a random matrix, size m by n, where I set both of them equal to 40. So this is a 40 by 40 matrix. And then it'll go ahead and display that matrix before Gaussian elimination has begun. And then in these loops, Gaussian elimination is carried out. So notice I have 3 nested for loops. By the way, you notice that here everything is nicely indented. And you've seen that in other statements I've written. So here we have the body of this outermost loop indented by 4 spaces. Body of this inner loop is indented by another 4 spaces. And then the innermost loop indented by again another 4 spaces. Now, if you're using a MATLAB editor, as you're typing this code out, MATLAB will, as best it can, indent for you. So notice, like for instance, if I only type up to this point, this for statement, and I hit enter, notice it puts the cursor right here. So it's figured out I'm in the body of the for loop, so it's going to indent. But sometimes if you're making a lot of changes to code, you're moving things around, the indentation might be off. So MATLAB makes it possible to fix the indentation for you. Because notice up here it says indent. So, like for example, if I just purposely mess up this code, I'm just going to put things all over the place. Let's make a mess. Please do not submit code like this. Now, MATLAB will still process this code, there's nothing really wrong with it. It's just uncycled. Okay, so now if I want to fix this, for example, if a student does turn in code like this, I can't stand to look at it. So here's an easy way to fix it. If I select it, and then I click on this button here after indent, fixes it. So this is a smart indent feature. Alternatively, you can select it and do Control I if you're in Windows, or Command I on Mac, and that will do the smart indent. So it's happened many of the time, because what I'll do is, as time permits, when I grade, I open your code and look at it. Sometimes I can tell right just by looking if something's right or wrong, and then run it. Sometimes I've written scripts that will run your code for me. And like here, I know what the result's supposed to be. Do you produce the same result? If so, you match, you get full points. That's all that's what I'm doing. I walk through your code, like, oh, I gotta fix this, smart indent now. But I appreciate if you not let it get to that in the first place. Because you don't want me to annoyed when I'm grading. Okay. So in Gaussian elimination, entries are zeroed one column at a time, going from left to right. So J refers to a column. So inside this loop, Gaussian elimination acts on the column J. So what I'll do is, in here, in this loop, its job is to perform a row operation on row I. So everything in here is meant to eliminate the element in row I, column J. So we figured out the multiplier for row operation. That will cause the element to be eliminated. And then in this loop, we can actually perform a row operation. So row I is equal to itself minus the appropriate multiple of row J, and that zeroes out element ij. Now, so we see here, J works on all columns, 1, 2, 3, except for the last. Because when there's a square matrix, you have no need to do any elimination in the last column. Here, I is going from J plus 1 to M. So in determining the proper range of rows, you're allowed to use this value of J that was determined here. So I will start at the row below row J and go all the way to the bottom. And then when performing a row operation, we'll start at column J and go all the way to the end. There's no need to work on columns to the left of column J, because those entries are already 0. So here we have loop, we're going to loop, we're going to loop. Once the Gaussian elimination is done, then the updated matrix, because A has been changed during this time, the updated matrix will be displayed. Now before I run this code, I want to point out this code. This right here is equivalent to what this innermost loop does. Because here we have an explicit loop. But this statement would do the same thing. Because notice, whatever I put for k here, k is j up to n. That's what I haven't filled in for k here. So I can take row I, columns j through n, is equal to itself, minus the multiplier, times elements j through n of row j. So sometimes you can code it this way. You have to be careful about when you do that. But in this case, it works nicely. So at least the code is a bit more concise. And the same operations are still happening. It says here we have an implied loop, since it's working on elements from j to n in these rows, as opposed to an explicit loop here. So that's your preference.
But the bottom one will be faster.
That's the funny thing is that it's not entirely clear. They've done a really good job of optimizing explicit for loops. I've tried this in some cases, and it's actually pretty competitive. But I know you think that this would be better.
It's vectorized code.
Yeah, and that's what this is referred to, vectorized code. And in certain other situations, I have used that to for the sake of efficiency, where perform operations on entire vectors or matrices at once. But yeah, I guess for more straightforward for loops like this one, they've done very well on optimizing those things. But any questions about what this code is doing and how the loops work? If I run this, okay, there's a lot of output here because it's a 40 by 40 matrix. Okay, so here's the original matrix. So here we have a full 40 by 40 matrix. Before Gauss elimination. After Gauss elimination, the intent is to make all entries below the main diagonal equal to 0. Although notice that 0 takes on different appearances. Most cases it just shows a 0, but notice we have 0.0000. Here we have minus 0.000. That's because of round-off error. That these elements are very small, but they're not exactly 0. So that's something that generally happens. In fact, I'm surprised that there are this many true zeros in here. Okay. But aside from the different appearances of 0, we can see that all the entries below the main diagonal are essentially 0, except for some rounding error. And rounding error is something that I'll talk more about when I get to chapter 2. Okay. Now that's as far as I needed to go in the tutorial itself, but we still have 15 minutes left. So we have plenty of time in case anyone has, like if anyone's got started on homework 1 and the explorations in there, if you have any questions, this is a good time to ask. So that was not due for a while, and we did just have a major storm. So I don't understand or not, but no. But I try to make time for questions during class when I can. You also get out early. Okay, fine. All right, so we have, if you look at the site, oh wait, okay, yeah, not due for quite some time, so, well, okay, 2 weeks from today. So we have 2 more class sessions devoted to MATLAB, so Thursday and the next Tuesday, which will bring us up to the 9th. Wait, no, it's the 7th. Yes, 7th. So a week after that is when it's due. But since there are quite a few problems here, even though I did cut out some particularly painful ones, it's not good to let things go to the last minute. But also around not too long after that is when the second homework will be due, because I'll spend 1 week covering section 2.1. Look at the assignments. Okay. Yes. So after that, you'll see a homework due like 1 week apart. So once you get this one done, you want to be sure to hit the ground running pretty soon with the next one. Because that there's so much MATLAB to cover. So set aside this much class time for it. Okay, so I'll post this diary. Yeah, just shut that off. And then these 4 M files will all appear in Canvas. Alrighty. Stopping recording now.